Good afternoon, everyone. This is June Riley, CEO of VC Task Force. Thank you so much for joining us today. As you know, VC Task Force is an organization that supports the venture community by addressing issues of the day. We have a number of programs for investors and a number of programs for entrepreneurs. This is a program for investors and entrepreneurs. So without further ado, I'd like to turn the floor over to Gary.
Great, June. Thanks so much. I look forward to the show today. My name's Gary Fowler, everybody. I'm a serial entrepreneur and investor. I've done 17 companies, been involved in 2 unicorns. I was on the original management team of Click Software, sold to Salesforce for $1.35 billion, and also Yva.ai, an AI HR tech company that I co-founded 5.5 years ago now with Dr. David Yang. Love artificial intelligence and quantum computing because AI is the new electricity. And of course, quantum is a turbocharger. So without further ado, I'd like to introduce my special guest, Vipindas Chengal, Dr. Vipindas Chengal. So Dr. Chengal has an incredibly interesting company called MayaMD.ai. And it's interesting because, as I said, over the weekend, I got to spend some time at Stanford, and I talked to some of the doctors there. I'm very, very excited when I find doctors that have crossed the technological boundaries and look at AI and artificial intelligence to be able to help us make some better decisions. So he's had an incredible background as a core faculty of Mountain View Internal Medicine. I did a residency there. Worked at SSM Health as a faculty member, currently a faculty member in Las Vegas. He's worked at Wayne State, Wheaton Franciscan Healthcare, and Stroger, where he did his residency. So it's with great honor and without further ado, great to have you here today. Thank you.
Thank you. Thank you, Gary.
Yeah, so tell me a little bit about, so what's the journey like? Where'd you grow up? I see Hindi, that you speak Hindi. Are you from India originally, or where are you from?
Yes, I am from India. I did my med school and residency in India before coming to the US in 2008. And I did my residency at Cook County Hospital. That's one of the busiest emergency rooms in the country. And a lot of times patients have to wait sometimes 12 to 15 hours in order to get into an emergency room at Stroger, Cook County. And I thought if we can predict what can happen to each one of them without, even before the doctor can, have a chance to talk to them, how many of them would need an MRI scan? How many of them might need a neurosurgery consult? How many of them could be treated as outpatient? Then we can dramatically improve the efficiency, right? So that's how, we started this project. I finished my residency in 2011 and been working as mostly in academics as a teaching faculty. And I started the research project in 2013, working very closely with a number of universities, over the last 8 years and built this system. I wanted to build a, tool that mimics a clinician's cognitive strategy in various, different clinical scenarios, whether it's symptom assessment or lab tests or symptom past medical history, an entire clinical case, or chronic disease management, or any sort of, clinical questions such as, preoperative surgery, preoperative evaluation, or postoperative care. So that's what we wanted to build, and that's what we built. It took some time. But I'm happy, about where we are now.
No, that's great. And so you came over from India. By the way, I got a question for you. Why are there so many incredible Indian doctors? I mean, is it a focus of your not only undergraduate, but your high school system? Is it math and science oriented? Why is it? I mean, it's just like incredible. It's like I said, I was in Stanford last weekend, and so just an amazing amount of Indian doctors. Why is it? I mean, it's incredible.
Well, growing up back in time, I mean, the main option for good students is either to be a doctor or an engineer. Unfortunately, starting a company was never an option. We haven't seen, too many entrepreneurs. So you either go to medicine or engineering, and we start very early. I started med school when I was 17. So,
17?
Yeah. That's, after the 12th grade, you have this common entrance test and you get into med school.
Wow, that's amazing. So from 17 years old, you go forward, you get into medical school. That's incredible. I was wondering why that, places like IIT focus on technology. Interesting. So how did you bridge your gap? So you just said to me that that you're focused on medicine, but at the same time, it sounds like you're a startup entrepreneur.
Yeah, that is right. Because I realized that there's a lot to offer for technology to improve the efficiency of the system, and there is this scalability factor. So that's what I really liked about technology. You can scale it up. There is a significant shortage of physicians, even in the US. Coming up. How do we solve those? And even if you look at the practice of medicine, I don't know if you know this statistic, but 5 to 15% of all diagnoses are either delayed, missed, or wrong. Okay, and
5 to 15%
of all diagnoses are either delayed, missed, or wrong. So that has to do with, there are many factors, but one of them.
I'm concerned which ones are wrong.
Yeah.
You know what I mean?
15% is 1 in 6, right? I mean, you are in the
Yeah.
So
yeah, that's incredible. What an interesting statistic.
Yeah. So, and diagnostic errors are the most, one of the key, factors that leads to bad outcomes. And one of the key reasons for it is cognitive errors. Human brain has a lot of, the imaginative power is unparalleled, but at the same time, there are cognitive errors such as premature closure. You try to get to a conclusion before you have all the information. So
well, how do you know when you have the information? That's the problem, right?
That is the problem.
How do you know what information you need? And here's the other thing, so on one side, you've got the GI doctors. On the other side, you got the surgical team. They don't talk all the time, do they? They don't share information.
That is one problem for sure, right? Being fragmented is one problem. The key issue is when you have when you have a new symptom and you go to a family, primary care doctor or emergency room doctor, a lot of times whatever comes to their mind first, they get to think that is the diagnosis. We call it premature closure, or anchoring bias. And I'm sure you must have heard of that. And I mean, if you look at aviation, one of the ways they tackle that is by having a checklist. So this, when we initially started, we wanted to build this checklist for literally any clinical question. That's how we started. And we work very closely with the Society of Improvement of Diagnosis in Medicine. In fact, Dr. Mark Graber, the founder, is on our board. So I thought, building these, checklists and the scalability factor, there's a lot technology can offer. So that's how I thought, just more than being a practitioner, I love, practicing medicine, but, adding the scalability and adding tools or giving tools to make the entire system more efficient would be a good, would be the way to go.
So tell us a little bit, how does it work?
So as I mentioned, the core engine can process any number of symptom, signs, lab tests, come up with a list of differential diagnosis and workup, meaning what physical signs look for, what labs to take, what radiology is indicated, what specialists to see, how urgent it is. And all of this is done with a processing speed of 0.6 seconds.
So in terms of urgent, how does it know?
So pattern recognition. So we built a huge, so the way our system works is it's a 3-layered system, right? So the core layer is based on guidelines, textbook data, millions of data relations that we've built based on the guidelines. And then the machine learning layer is on top of it. And at the very top, there is the physician review. So initial 5 years, we spent building this, this huge database we arranged it in such a way that, let's say a physician has unlimited time and resources to make one decision at a time. What would he look for? And that's how we arranged the data.
Tell me that again. What is it? So how would they
So,
look at the,
pattern recognition. So we,
I understand that, but how would the clinician, the doctor use it?
so do you want me to do a demo or?
No, just talk to me about it. I'm
Yeah.
really curious.
Sure. So the way it works is, for a physician, right? Let's say I have a patient who has, 5 symptoms, 6 different lab tests, past medical history, etc. I type in all these, then our system generates a checklist. What are the things?
That's cool. I love that.
That's what it does, and that's for symptoms. So let's say there's another clinical question, such as I have a patient who's going for gallbladder surgery, and he's taking these medications. And what is the surgical risk? What is the what are the when to stop certain medications? What is the bleeding risk? All of this, our system can analyze and come up with a checklist.
Wow,
So
that's cool. Now, how many customers do you have today? How fully deployed is it?
So initially, our focus was building this physician-facing product. We built, tools for doctors, and that's when I mentioned to you earlier. We did work with Stanford, Johns Hopkins, University of Utah on this glaucoma project, and then we worked with the core teaching faculty with Yale to build this clinical reasoning engine to help with training medical students. A couple of years ago, we have seen significant amount of interest in the patient-facing market. So we built a tool that is facing patients. So it's in a very advanced symptom checker. If you're familiar with that term, it's a very advanced symptom checker. It can suggest, whether the patient is appropriate for telemedicine or not, or self-care, or urgent care, or emergency rooms. And then on the other end, it generates this decision support for the provider. Now it's deployed at Motive Health. That's an insurance company in Utah. So we do this narrow network strategy. So we combine Motive, our technology, and send all the patients to Steward. Steward Health, as you know, is one of the largest privately held hospital system in the US. So we triage the patients, we avoid leakage, send the patients to Steward ERs or Steward urgent cares. Steward also a risk-taking organization, so they don't want unnecessary emergency room visits.
Right.
That's one place that we are currently deployed. We have several other deployments coming up actively, and overseas too. We work with a number of institutions and companies. We have a partner in Colombia. We have a partner in Taiwan, in India. An international organization called Smart Village Movement. And yeah.
So what are you going to do? How are you going to commercialize it, get it out to the market?
Yes. So what it does is, for insurance companies, it avoids unnecessary emergency room visits. You know that about 40% of emergency room visits are unnecessary. Patients can be treated as outpatients.
Wow, 40%?
Yeah. So if you
tell me like what would be considered unnecessary. So out of that 40%, give me a couple examples.
So let's say you have a condition that requires just antibiotic and wouldn't require immediate care. For example, let's say UTI, right? You need antibiotics, but you don't need emergency room care. You're not having a heart attack, right? So filter those patients out and send them to the telemedicine. Right now, telemedicine is just a video, right? We triage the right patients to telemedicine. We filter the patients out of the emergency room. As you know, emergency room costs tens of thousands of dollars. So that is the key thing that we are offering.
Yeah, for each visit, right?
Each visit, every visit.
What's the average cost in emergency room today? Like average, how much what do you think?
I think it's about $6,000 to $10,000, $6,000 to $10,000.
Can you imagine $6,000 to $10,000?
Yeah.
Wow.
Yeah. And then outpatient visit is about $200. Telemedicine might be much cheaper. Could be like even $19, like $20.
Wow.
So if we can do that efficiently, that really changes things. And there are some symptom checkers out there which does this, but For us, our system is the most accurate and comprehensive and the fastest tool. So when I say accurate, we recently did an accuracy study with faculty from UCLA, faculty from Michigan, and Utah, and our system did outperform doctors.
Really? Does what was the outperforming in what ways?
So these are for each case, we gave it to the doctor. They have to decide where the patient should go to, whether it's appropriate for urgent care versus emergency room versus self-care, telemedicine, etc. And then doctors individually come up with, the answer, and then they sit as a group. Now we had 3 different groups. One is emergency room providers at Michigan, and then internal medicine and hospitalist group at UCLA, and then there's University of Utah. So they sat together and come up with a consensus. So they compared each individual physician's triage and Maya's triage to their consensus. So they are actually comparing with their own group's consensus.
Wow, that's amazing.
Yeah, so there are a couple of doctors who did outperform Maya, but on an average, Maya did outperform individual doctors, 82 to 94%. So
82 to 94%.
yeah, that's right.
Wow. And so, so you're saying emergency rooms, because they have such a 40% are not diagnosed correctly, et cetera. So it seems like why is that anyhow? Is it because of time? Because they don't have a lot of time to make a decision, or what?
No. So diagnostic error is a little different. What I said is emergency room visits per se is unnecessary. That's
I got it.
Cognitive errors is a different
To the
issue.
emergency room because it's not that big a deal.
Correct.
So why wouldn't they go to an urgent care or something like that? Wouldn't that be a better option instead of an emergency room?
So if let's say you're having, let's take the example of let's say gallbladder or a pancreas, whatever, right? That requires a procedure, that requires hospital admission. So they need to go to an emergency room because they require admission. Urgent care is not designed for that. If you go to urgent care and if you end up having an emergency, then you have to wait until you get transferred.
Yeah, got it. Yeah. So, but how would you know? The problem is, if the only thing from my standpoint, how would people know? The problem is they don't know what they don't know, right?
That is correct. So that's why tools like this can help.
That's exactly what I'm saying. So give me a typical use case. How would this be used? So how would somebody doesn't feel well? I see in San Francisco, there's a new type of, and I forget the name of it. There's a new type of facility up there where you come into it, they're doing scanning you and doing all these. It seems like it's a next level of medicine, but how would a patient engage with you?
So, there are a few ways. One is, through their insurance company's portal, their patient portal, they go in, and then Maya suggests telemedicine, and then Maya links to a telemedicine provider, and you get antibiotics and you're done, right?
Right.
Maya can say urgent care, and then you go to an urgent care with the network. Now, however, there are certain symptoms, a computer software cannot really assess properly. For example, like chest pain or severe abdominal pain. It's very hard. For those cases, Maya by default might send the patient to emergency room. However, whenever there is an ER recommendation, that information is going in real time to the nurses.
I got it.
And they call the patient and find out what exactly is going on. So instead of, let's say 10 people are checking symptoms and 3 of them are ER visits, maybe only 1 needs to go. But the nurse can call these 3 and figure out that 2 of them can be seen, over the phone or urgent care. So
that's where the point of intervention in terms of.
That is correct.
Right. Interesting. Okay, cool. So what are your plans? Tell me a little bit about your plans in terms of how you're going to get this out to the market. I mean, are you going to be the business development driving this thing, or how are you going to get it out to the market?
This narrow network strategy is actively considered by many health systems. We had a great call with Florida Blue the other day. So Stuart, we are creating this narrow network between an insurance company and the health system. Now the health system is taking us to different insurance companies.
That's cool.
So it can be done, through our existing partners. So that's one way of doing this. The second way, second is, selling directly to health systems. We have this, Maya is not just a symptom checker, but a full-fledged personal health assistant, right? So let's say you had a surgery, and post-surgery you have some questions, or let's say the wound, you need to make sure that the wound is not getting infected. Maya can actually help with that too. So that product we try to sell to health systems.
So tell me a little bit about that. I'm interested. How can Maya help you with a wound?
So Maya, as a personal health assistant, can help you get into the hospital, help you during the hospital stay, answering questions and all. I don't know if you're familiar with HCAP scores. There is something like it's called HCAP scores. Medicare payment is based on the patient satisfaction scores of a hospital and providers. Right. So all the hospitals.
So what does that mean? Does that mean they get more money if they satisfy the patients?
Yeah. The reimbursement is affected by better satisfaction.
So is Maya compassionate?
I think so.
Yeah, because if you look at the next level of this thing, when you talk about, we talk about, I've written a lot about assistants, right? Not smart, but intelligent assistants.
Yeah.
Kind of like what you're saying, but in a broader scale, but it's not just for health, it's for everything. Having a Maya there that cares about you, where you can go down through and, whether it's health or whether it's a relationship thing or whatever. I mean, it's almost like, you're actually like a smart mother.
Correct. It's not just compassion. I'll give you an example. Like, let's say you had a surgery, right? And the doctor is spending just 5 to 10 minutes with you, right? That's it. Maybe you're unable to ask all the questions. Maybe you don't remember all the questions, right? Maybe you're unhappy with something else. There is no way the hospital is knowing that you're unhappy when you are there. So Maya can actually
care though. Vipindas, seriously, I'm, having just come from an experience at a hospital. Did they really care? Do they have time to care?
The doctors?
Yeah.
Because of the HCAP scores being very important, they have to get patient satisfaction to be the highest. So it's a requirement.
So because they're driven, so they're going to be, so that forces them to not be as cold and to be more compassionate. Yeah.
Even if they're cold or if they don't have enough time to spend, at least you can interact with our technology. And if you, let's say,
so that kind of replaces or enhances that part of the relationship, right? Because that becomes part of the whole journey.
Exactly. There are a few questions that the patient needs to answer, or the hospital needs to get 10 out of 10. One is, did the provider answer all the questions?
Right.
With respect and compassion. Those sort of questions. Maya can answer a lot of questions, and the chance of hospital getting a better score is much higher with our personal health assistant. So that is what
I want to just add one thing. Now, tell me about this. And I'm not sure if Maya has that capability, but one thing that I've seen being in the hospitals is that you need an advocate. You need something that can advocate for you. Could Maya actually become smart enough to actually advocate for that patient and to be able to go out to the doctors and start to push and, and use that same rating scale to make sure that they're actually interacting between departments and actually, and I don't know if that's a capability today, but what I look at as the future, of the health system 4.0 is really those kind of technologies, because part of it, you just can't collaborate. But if you had something that you basically not only watching over you, but helping, that could be really interesting for the patient journey. That could change things.
Yeah, even something very simple as, I forgot to ask this question, but the doctor or the nurse is not giving me the answer. You can actually let Maya know, and then Maya can actually convey this to the care team. So at least they know which patient is unhappy, what questions they have.
Well, they know that it's being accounted for, right? That's part of the deal. So you could tie scores into whether or not how happy the patients are and how much information is coming back on the other side.
That's absolutely right. And then what, once you're discharged, for example, let's say you need a cardiologist, you're diagnosed with congestive heart failure. Let's say my neighbor has a great cardiologist. I would rather go to that cardiologist.
Right.
But what we do is we create this narrow network strategy. So Maya follows up, post-discharge, answer questions, and all the answers are captured by the doctors within network.
Yeah.
So there is a reason for the patient to go to the doctors within network.
Right.
Questions such as, did you weigh yourself, or are you gaining weight? Things like that. Right now, when you're discharged, they're simply giving you some papers, right? That's it.
Yeah. There's not really, a nurse will follow up.
It is not
maybe.
correct. It's not really keeping the patient within network.
Because that's part of the problem, right? The part of the problem is it's great, you have point of service, but then when you come out, it's really, how do you monitor what's happening? And so if you had something like a Maya to be able to continually monitor, right? That's where the AI comes in, which is very interesting. Monitor what's going on, and then also alert it. And if you had like a nurse advocate, somewhere, that clinical, nurse practitioner someplace, that could basically be that line back into the hospital. So if something's going to be a problem, so insurance companies, you're listening out there, insurance companies, think about this, could save you a lot of money.
That is exactly right. And with Medicare, paying for remote patient monitoring, right? So we can, attach devices through Bluetooth or cellular, and we have our own telemedicine system, or we can work with telemedicine system. So we want to have this integrated experience with Maya, before visit, during the visit, post visit, chronic care, etc. So that's what Maya does.
I happen to have co-founded one of the health tech companies called Zemply. So Zemply's she's a MBA from, actually Indian MBA from Stanford University, and actually does remote patient monitoring. What you just said actually could be a nice, interesting hook. This is to be able to enhance the quality of life. Somebody comes home, because as you know, right, the will to survive is critically important for patients. And part of the problem we have is that, we institutionalize people, we put them in nursing homes, et cetera, but we could keep them home longer based upon collecting the data and in all kinds of ways, right? Could be like the European Space Agency, to go to Mars, has a device, an intelligent device that actually becomes your companion and to manage to look at your vitals, what's happening. I mean, it's like HAL from the Space Odyssey, right? But literally, this is really what the evolution is going to look like, because you're connecting the dots when you connect the doctors together, the nurses together, the follow-up, because part of it's a follow-up. What did they do? The other thing is set the appointments for you. Listen, I know you're going to be down in, Michigan or Las Vegas. Here are 3 doctors. And oh, by the way, here's one, one of these persons through your contacts. Here's somebody that might be interesting for you. It's really becomes an end-to-end solution. I love what you're doing. So how big's your team?
So we the tool was built with about 25,000 physician hours and about 20,000 engineering hours. We have teams in the US, in India, in New Zealand, and in Argentina. And our management team has about 8 to 10 people in the US. Recently, we got Mr. Nasir Hashim into the team. He sold us. He had the largest radiology company in the US, sold to KKR for $300 million. So he's part of our team now. Mark Kozak, he's also the CEO of Telluride Research Science Center. He's a COO. Christian Haberman is the chief marketing officer. We also recently have Mrs. Karen Hiteshi. She recently sold her company for $350 million, 2 transactions. So our team.
How big is the company? Vipinda, how big is the company today? What are your annual sales?
No, we have been in research and development until last year. We are actually coming out. Yes, we have a sales team in the Middle East. We have a collaboration with a group in Kuwait called Al Ghanim. They're a $10 billion company. Mm-hmm. In the US, we released our app last year this time, and we are adding all these capabilities. Now we are live with the insurance company. A lot of deals are in the pipeline.
That's great. Well, congratulations. Listen, we're coming to the top of the hour. I want to thank you very much for joining Gary's Picks today. I want to thank the entire VC Task Force team for making Gary's Picks possible. My name's Gary Fowler, and with that, June.
I would like to thank both of you for this interview, and I think what you're doing is absolutely fabulous. Healthcare to me is right now is kind of scary. And so if you can take some of the fear out of it and some of the inaccuracies out of it, that's terrific. So I look forward to seeing your product. I look forward to seeing more of your product.
Fantastic.
So
Thank you so much. Thanks for having me.
Thank you.
Yeah, congratulations. Look forward to it. And I want to introduce you to Zemply, the company that I co-founded. It could be interesting for you. So thanks, everybody. Stay tuned. In 2 weeks, we will be back with another episode of Gary's Picks from Silicon Valley. Thank you very much. Stay happy, stay healthy, stay safe, and keep smiling.
Awesome.
Thank you so much. Take care now. Bye-bye.